Hello everyone, myself Rakhi, Assistant Professor in the Department of Electronics and Communication Engineering, ABS Engineering College, Ghaziabad, affiliated to Dr. APJ Abdul Kalam Technical University, Lucknow. Today in the lecture series of optical communication, I am going to discuss before you different types of multiplexing technique and the free space optics. So, before going through the content, just have a brief introduction about the multiplexing technique. Multiplexing techniques are basically incorporated in the optical communication so as to increase the capacity or to get maximum from the optical system. So, now in this particular contest, I am going to deliver before you different multiplexing technique. The first one is the optical time division multiplexing, electrical time division multiplexing, wavelength division multiplexing, subcarrier division multiplexing, and at the end we will discuss about brief introduction about the free space optics. So the first one, the optical time division multiplexing. So whenever something comes from the optical side, that means the signal will be of light, and the time division multiplexing. Multiplexing is to incorporate. So whenever we talk about the multiplexing is basically combining one or more, 1, 2, 3, 4, a number of signals into the one. So many to one is basically the multiplexing technique. So here I am doing that thing. Optical pulse, which is the source of an optical signal, and the light, which is the main element in the optical system, is having a pulse stream of TB. Now it is going through the modulator, because modulation is a very important process. About that which we have already discussed, and the different types of modulation technique which will be used will be either ASK, OK, that is on off keying, amplitude shift keying, FSK, that is frequency shift keying, and PSK, that is phase shift keying. And after modulation it will go through the fibers, which is our optical fiber, and here it is divided to many, and then again it is combined here. So to booster and pre-amplifier, and the end there is a demultiplexer, so as to convert this one signal into many. So in this case we can say that both the multiplexing and the demultiplexing, first many signals are uncorporated and it is converted into one, so as the multiplexing is done, and at the end one signal which is transmitted get into number of receivers, so that maximum can be achieved from this one optical fiber. So what we are seeing here, that already we have told that this multiplexing techniques are basically incorporated for achieving maximum out of the optical fiber or optical system. So what they have done at the beginning, that they have gone through the signal is emitting, and from the different modulator it passes through the different modulator, and we have 4 types of signal, for example here, which is represented by A, B, C and D, and combined pulse stream is here for one, and the space is available. So it is incorporated with 3 different types of signal again, so as to complete the complete pulse stream. Now these 4 are combined, multiplexed, and it is passed through the optical fiber, and here it is combined in the one single form, and in the demultiplexer end, which is at the receiver section, it is again divided into 4 and so received by the 4 different types of receiver. So by using a single optical fiber transmitting medium, we are transmitting the signal to the 4 receivers. So what we have achieved now, we have achieved maximum from this one. We have from one optical fiber system, we have received signal at the 4 destination. So these are the advantage of using multiplexing techniques. So OTDM multiplexing follow the same operation which is for the ETDM, which we will going to discuss in the next slide. Different optical pulse stream called tributaries originate from the same laser. It is originating from the same laser. The aggregate channel speed achieved are of the order of 100 to 250 gigabit per second. Then n digital bit signal in the baseband modulated at b bit per rate uses the same optical carrier. So in this case, what we the example which we have shown, we have used the 4 digital signal, and all of them are baseband modulated at the b bit rate and uses the same optical carrier because the same optical fiber are used. They are optically multiplexed. We have seen that they are multiplexed. The many signals are into one in the time domain to obtain nb bit per second, because here it is 4b bit per second because we have a 4 digital signal, where n is the number of the optical channel. An optical transmission is a OTDM system is a laser able to generate periodic optical train of pulse with the same optical period TB. So the different channels which are originated from the laser will have the same period TB. All the 4 signal which is shown here ABCD will have a same period TB. As a resultant period, that one channel represent a bit rate B. So the pulse with TP must satisfy this condition. So what are the coding which is required by this OTDM? It requires the coding of RJ coding. So this multiplexing techniques are used in the case of a optical system. The another one is the electrical time division multiplexing, and we can able to see that this is approximately same as the what we have discussed earlier, that is optical time division multiplexing. Here also pulse TB and different type of first, second, third originating from the electrical end, and it is combined with the help of multiplexer. And now there is this optical source that will convert this till the signal are electrical. In the previous case, from the starting the signal are in the optical form, but here in starting the signal are in the electrical form and it is multiplexed before conversion to the optical one. In the first case which we have, so OTDM, the signals are in the optical form and they are multiplexed and then they are transmitted. But here what is going to happen? Electrical signal are first multiplexed, then they are converted into the electrical form. This is the one difference between the OTDM and ETDM technique. Otherwise everything are same for these two techniques, and then it is transmitted into the optical fiber, and this case light is the carrier. That's why we consider it in the case of a multiplexing technique in the case of optical system. And when this is received at the receiver section, again this optical signal is converted into the electrical one with the help of photodiode, and when it is converted into the electrical, it is demultiplexed. So to provide signal to the 4 receivers. So the difference between, first we have to see the similarity between the OTDM and ETDM. Then the technique are time division, multiplexing for both, but the difference is that in the case of OTDM, this signal are multiplexed when they are in optical form, but in the case of ETDM, signal are multiplexed when they are in electrical form, and then it is converted into the optical one. A broadband optical system transmitting an aggregate time multiplex signal in the electrical domain after modulating the optical source. What are the features? ETDM system are based on multiplexing digital signal. Multiplexing and demultiplexing are always performed in the electrical domain in the case of ETDM, but in the case of OTDM it is performed in the form of a optical domain. Today ETDM are the most used type of multi-channel system in the backbone network. This system from the core of the most advanced transmission technique. Commercially system in operation is 2.5 yard 10 gigabit per second, commercial system at 40 gigabit per second in development and deploying process, systems at 160 gigabit per second in R&D process. The next one, that is the wavelength division multiplexing, which is also called as the WDM. So what is the main thing? In the case of OTDM and ETDM, the signal in OTDM, optical signals are used for the multiplexing in the time domain. Time in the ETDM, electrical signal in the time, but here wavelength is multiplexed. So it is used to increase the system capacity. So how to increase the system? By wavelength division multiplexing. So if the initial bit rate is BI, now it converted into 8 BI. So 8 channels are created from the single one, increasing the bit rate per channel, limit in the electronics and sensitivity, the dispersion effect. So it will also reduce the dispersion effect. The second option is, first with the 8 channel, we can also have it in the 16 channel or in the n number of channels. By increasing the number of channel at the initial bit rate will remain the same, and keeping the bandwidth implies arising non-linear effect. But in this case, when we are increasing the number of channel keeping the bit rate same, the non-linear effect, for example FWM, which is already discussed by you, 4-way mixing and the crosstalk in filtering and demultiplexing. The second one, third option is a 16 channel, and in that what we are doing, increasing the total spectral bandwidth by increasing the number of channel at the initial bit rate and the same spectral separation. So what we have done here in this option 2, the spectral separation between are reduced. That's why this non-linear effects are arising. So just to reduce it, this non-linear effect, we have designed the third option. In that case, increasing the total bandwidth by increasing the number of channel initial bit rate and the same spectral separation. The separation which is at the initial condition will remain the same. Here you are able to see that this separation is reduced. That's why the crosstalk or the non-linear effect are prominating in the case of in the second option. So just to reduce that, here bit rate maintains same, but separation is also maintained same, so as to reduce the non-linear effect of the crosstalk which is arising in the case of option 2. Now just look at the multiplexing technique, WDM. Here it is a wavelength lambda 1, lambda 2 and till lambda n, and it is multiplexed. It is converted into 1, already told that it is many to 1, and when it is converted into 1, it is transmitted through the optical fiber link, and at the receiver section what is going on? Either we can use splitter or we can use demultiplexer so as to convert the one signal which is carried by the optical or the light into a number, and here also the same thing. And then what is going to be happen? Optical receiver filtering techniques and other photodiodes, it get encountered with photodiodes so as to convert into the electrical signal and get received at the receiver. So the main thing is here is the wavelength. Now the subcarrier division multiplexing, which is SCM. SS network does not usually carry high bit rate, though the number of channels can be extremely high in many SS, LAN and MAN network. Subcarrier division multiplexing offers the transmission capability of a multiple channels simultaneously by the RF subcarriers. So in the first case we have seen that time, the second case also time, in the third one we have used the what? We have used the wavelength. But in all that case the carrier is the optical. But here in the case of subcarrier division, RF subcarrier, any RF subcarrier can be used. We can easily know that optical is also a sort of a RF carrier. That's why it is comes under the subcarrier division multiplexing, comes under the category of optical multiplexing technique. SCM offers a huge bandwidth over the same optical carrier, providing stability. So what is the advantage of the SCM? It offers a huge bandwidth, providing stability and flexibility to combine different kind of services, which is include formatting, bandwidth, etc., voice, data, or digital audio, TV, HDTV, video on demand. So maximum various kind of services can be accomplished with the help of SCM, because with the same carrier, optical carrier, it provides a huge bandwidth. So SCM is used to transmit RF signal over copper and fiber link in a metropolitan SS network. So where it is used? Fiber plus copper in HFC technology, hybrid fiber coaxial, formerly CATV network, fiber, FTTS technologies, in particular fiber to home technology. Resultant mux signal is directly applied to optical. So these are the various scope of the SCM. So now how it is done? It is different type of services, service 1 to service N, and the carrier here is the RF carrier. They are combined here, and it is then it is given to the optical transmitter, which will convert this signal into the electrical one, optical one, and when it is converted into the optical, it is transmitted to the fiber, and at the receiver section it is received, and again it is going through the different filtering and the processing technique. So RF modulated signal multiplexed into a composite signal for providing a high bandwidth configuration based on optical sources directly modulated. So there is a resultant modulation power intensity at the entrance of the optical fiber. This is a general expression of the modulated signal. So the main reason here, again we are using the optical system for transmitting of signal. That's why we can include it in the optical transmitting multiplexing technique. Now comes to the free space optics. So what is meant by this free space optic? Free space optic is also called as the FSO, transmission of visible and IR beam through the atmosphere to obtain optical communication. So when signal are transmitted through the visible and IR beams through the atmosphere, then it is called as the free space propagation. Free space of course means air, outer space or a vacuum. Line, it follows the principle of line of sight propagation, which is also called as the LOS. Primarily it It is of two types. First, by using the LED transmitter. So in the free space optic, what's the difference between the normal optical communication system and the free space optic? In the free space, the transmitting medium is the visible and IR beams, not the optical fiber, which we used for the optical fiber system. So this is the first difference between the free space optic and the optical communication system, which we have studied till far. So you have to just go through the introduction part of this free space optics. They are primarily of two types. First, using LED transmission, and using LED transmitter we can use the free space optic for short range communication, and it produces the incoherent light, just as the LED source. LED source is of course emit the incoherent light. Already you have known about this when we have studied about the sources. Using laser transmission, long range communication is possible, and it produces the coherent light because laser is a coherent source of light. So just have a system overview. Use a directed beam of radiation between the transmitter and the receiver. So already told you that here exists a transmitter and the receiver, but previously in between the transmitter and the receiver we have a optical fiber, but in the free space optics, in between transmitter and the receiver, directed beam of light radiation. There exists a free space, and the visible light or the IR radiations are basically is the medium which is used for transmitting the signal from the transmitter and the receiver section. And since the visible light are used, that's why it comes under the optics category. So in the FSO system consists of an optical transmitter, an optical receiver, and a transmitting medium, which is our free space. Use both lengths on both transmitter and receiver, and its maximum range is about 4 km. This is basically a diagram of a FSO. First, you can able to see that this is similar as compared to the optical system, but the difference is the transmitting medium here. First, the source data, electrical signal driver, modulator which will modulate the signal, and in between we have a laser or a LED which is our source of the optical signal, and optical amplifier because the intensity of light which is generated by this is a very less. So our amplifier is basically added for the amplification purpose. Then a transmitting medium which is our atmospheric channel now comes to the receiver point. This all comprises of the transmitter, and these are the receiver one. Comes to the receiver section. First, the photodetector which will receive this optical signal from the free space and then convert it into the electrical one for the filter and the processing purpose. So just a brief introduction of the system working. Source, data to be transmitted. This is the description of the blocks of the different blocks which we have used in the block diagram representation. Modulator, perform direct modulation of message signal with the carrier signal. This is general definition of a modulation process. Laser driver, a device which delivers constant current to the laser diode for the smooth operation. Then laser diode produces modulated laser beam for transmission of atmospheric channel, which is the transmitting medium here. Medium through which laser beam propagates. Photodetector, convert received light signal into the electricity or voltage. Amplifier amplifies the converted signal for efficient demodulation, because the signal which we have received at the detector section also is having a very less intensity. Demodulator demodulates the received signal to obtain the transmitted message at the last destination receiving end of the data which has been transmitted. So what are the challenges which are faced by during the free space optics? These are the some of the challenges which are faced during the free space optic. First one is the obstruction. Obstruction in the path can hinder transmission. Already we have seen that in the features of the FSO that it follows the line of sight propagation. So, if any obstruction comes in the path, that can hinder the transmission. Fog, because it is in the free space, so this atmospheric condition will play a very prominent role in the transmission. Aerosol consists of water droplets and ice. It is the definition of a fog. And how it will affect the optical system communication? Absorption of scattering of optical signal due to airborne particles. Already when we have studied about the noises or the absorption process, that it will leads to the any water droplets or the ice which is present in the fog will either absorb the signal or lead to the scattering of the signal. Can result in incomplete outreach, can be alleviated by shortening link distance and adding network redundancy. So these are the effect which arises in the case of a free space optics due to the presence of fog. Then scintillation, heated air arising from the earth or man-made devices create temperature variation in the atmosphere, and this is called the scintillation. And how it will affect the free space optics? It results in beam spreading and the wandering, almost mutually exclusive with fog attenuation, result in increased error rate but not complete outreach, building sway and seismic activity. It will lead to the movement of building and can upset receiver and the transmitter alignment. So, another absorption, atmospheric absorption result in the power attenuation of the FSO beam. Scattering, when the scatterer is small, then the wavelength is known as the Rayleigh scattering. When the scatterer is of comparable size with the wavelength, then it is called the Mie scattering, because in the droplets or etc. any particles which are present in the atmosphere will lead to the scattering of the signal, and this of course affect the FSO, that is free space optics. And but when we have a challenges, we have advantage also. So these are some of the advantages of the FSO. Installation cost is very low when compared to optical fiber transmission. No licensing required like RF. Immunity from electromagnetic interference. Deployment of SO system is quicker and easier. Data is highly secured. No need of trenching and digging land, because in the case of optical fiber establishment, we have to go through the digging of the land. And of course, when the data, someone picks the data in between the transmission also by from the fiber which is inserted inside the, and whenever there is a fiber flowing, there will be the cases of electromagnetic interference. So in this case, there it is immunity from the electromagnetic interference. High data transmission rate of 2.5 gigabyte per second, unregulated spectrum, and hence huge bandwidth is available. Now the disadvantages of FSO. Transmission rate is weather dependent. Already we have seen in the challenges faced by FSO that it is highly dependent on the weather conditions. If sun goes directly behind the transmitter, it can interrupt the signal. Distance is limited. Of course, it is for the 4 km maximum. High launch power can cause eye hazards. Transmission rate is affected by the environmental factors like fog, snow, rainfall, etc. Atmospheric barrier and physical obstruction can act as a because of course line of sight propagation is the major factor which is associated with the free space optic. So whatever the disadvantage which we are showing here in the FSO are basically due to the challenges which is faced by the FSO. So now the application of the FSO, enterprise connectivity. It is used to communicate between spacecraft as lower chance of disturbances of the signal. Military and government application for secure data transmission. Disaster management causes due to the ease in setting up the network. So these are the some of the application of the FSO, and thank you for attending today's class.